Good afternoon, everyone. This is Professor Vikas Vasantrao Mai, Assistant Professor in Mechanical Engineering Department from TSSMS Bhirabai Sawan, College of Engineering and Research, Nare, Pune. As per the subject-specific environmental awareness task given by Dr. Vinay Kulkarni, co-coordinator of International FDP on Environment and Sustainability, I am going to discuss few points of sustainable advanced manufacturing process. As far as previous week video details, I have prepared video on introduction to study sustainable behavior approach in various manufacturing processes in week 1. For this, classification of advanced manufacturing process incorporated with sustainability with excellent productivity and good economical health of industries we had discussion. Also, case study of micromachining techniques used to fabricate miniature parts having complex geometry and specified micro dimensions. In continuation with this, in the week 2, I had an assignment on innovative clean energy technologies in advanced manufacturing process. For this, I have prepared one YouTube link with which I have given an overview of manufacturing sector in India with some process parameters introduced in advanced manufacturing processes. Now, let us see the video outcomes that had completed in week 1 and week 2 assignment section. After learning through these videos, the students will able to study and classify advanced machining processes approaching to sustainable manufacturing development. Also, student will able to understand the current scenario of manufacturing sector all over the globe and in India also. To define and demonstrate innovative clean energy technologies in manufacturing sector and to understand specific objectives within each opportunity area were used to identify key technologies of interest for a balanced research, development, demonstration and deployment portfolio, that is RDD and D portfolio. Now let us move further into the introduction part of sustainable advanced manufacturing processes. Now, as we know, manufacturing technologies offer plenty of opportunities to improve sustainability by reducing environmental impact or by the more efficient use of resources. Some possible improvements in sustainability are related to processes, machines, or the overall system. Also, to realize the idea of green manufacturing, all production technologies have to be examined with respect to their possible contribution to the improved sustainability. Sustainability is achieved when the actual consumption rate matches the sustainable rate. And for that, the life cycle assessment is need to be done, which helps to investigate the potential for improvement in order to bridge the gap between today's consumption rates and the needed consumption rate to reach a sustainable state. Sustainability in ultra precision and micro machining. Now, as far as the Matvinga defined micro machining as a manufacturing technology that involves the use of mechanical micro tools with geometrically defined cutting edges in the subtractive fabrication of devices or features with at least some of their dimensions in the micrometer range, that is 1 to 999 micrometers. Also, Brinkmeyer has defined the ultra precision machining as a machining process whose accuracy has been driven to its sustainable ultimate technological limits irrespective of the nature of the process and the size of the workpiece, that is to micro, macro or nanoscopic level. So with this, ultra precision processes allows to achieve surface roughness down to the nanometer scale and are applied, for example, to manufacture optical components. Micromachining processes, on the other hand, are adequate technologies to manufacture microcomponents, microfeatures, and microstructures. Now, what is the sustainability aspects in ultra precision and micromachining? Actually, a suitable way to study the sustainability of manufacturing process is the life cycle inventory analysis. And based on the process or the procedure proposed by Linke to investigate grinding and input-output quantities of ultra precision and micromachining are defined as follows, as shown in the figure. So at the center we will see the ultra precision and micromachining processes, parameters, and chip formation or the cutting forces that are occurring at the time of machining. Those are incorporated with non-product material, product material, energy forces, and when they are combined with the worker, that workers are again incorporated with their health, education, then the machine with their life cycle, power, and whatever may be the waste coming out of that. It should be the solid waste, dirty cooling lubricant, emissions, tool wear, or heat. All these parameters are being incorporated while we are looking after the sustainability aspects in ultra precision and micro machining. Now, this is a diagram which shows the component size and accuracy in micro machining and ultra precision cutting. As we see, on the x-axis, we are defining the surface roughness with their geometrical error, whereas on y-axis, we are showing the component size. As and when the component size goes up to the ultra precision level, the surface roughness proceeds, that is near to the zero. And when we are obtaining the micro machining with the help of minimum component size, so that when we combine both these machining processes, that is ultra precision cutting and micro machining, so we will come to know the exact fabrication under the micro level, that is a micro fabrication technology. So for optical components, we are going to discuss these ultra precision cutting machining process with microprocesses. So to carry out all these ultra precision cutting as well as micro machining processes, we have to continue with green manufacturing technology ways. The green manufacturing technology ways includes efficiency improvements, carbon capture and storage from power plants and renewable power, etc. As we see in the figure, that is the concept of technology wages. Where are we today and where will be in future? For that, as and when we are going to adopt some technology in our manufacturing process, the consumption rate is going to increase day by day in future. But at the same time, the consumption with increased efficiency is going to be lowered down. That means efficiency is going to increase, but the consumption of the energy is going to be decrease. That is what the impact of green manufacturing technology with this wages. Now here I'm going to discuss some ISO IEEE standards or industrial norms with their applications. What we have studied earlier in innovative clean energy technologies and in sustainable manufacturing processes, there are some important industrial standards of the organization, that is ISO or Industrial Organization of Standards. They are defined as a first one is the ISO/TC 184. The main domain for this international standard is automation system and integration, and that can be used in the area of robotics, CAD/CAM, and manufacturing processes. Second international standard that is discussed for sustainable advanced manufacturing process is ISO TC 261. The domain area for this utilization of ISO is been additive manufacturing, and with various additive manufacturing process terms and definitions, process chains that may be hardware and software, the test procedures, the quality parameters, supply agreements, and all kind of fundamentals have been discussed under this ISO TC 261. The next standard, that is the ASTM standard, that is the ISO ASTM 52900, that is also deals with the additive manufacturing and that process categories and determining characteristics. Next standard that is being defined for sustainable advanced manufacturing, that is ISO/IEC/IEEE 12207 semicolon 2070 EN. This ISO standard is deals with system and software engineering. So whatever the software lifecycle processes are there into the advanced manufacturing process that are incorporated, that we are going to define by using these standards. And last but not least, the ISO 1404 FF, that is used in life cycle assessment format to assess the environmental impact of product, services, or systems on the environment. Now, how the carbon emission accounting is being carried out in sustainable advanced manufacturing process, that we need to learn. As a case study, I have just given one example. Now, first we will discuss what is carbon emission accounting. It is an important assessment method for sustainable manufacturing, which mainly focuses on raw material, energy, waste disposal factors, but ignores labor and capital factors. But however, the generation process of labor and capital is inevitably produce carbon dioxide emissions, so that the carbon footprint method is used to evaluate this carbon dioxide emissions of the manufacturing process, which is historically defined as the total set of greenhouse gases emissions caused by an organization, event, product, or person. Now, the carbon footprint method is widely used to measure the carbon dioxide emissions values as carbon dioxide equivalents, which is suitable for processes sustainability assessment and is also suitable for products life cycle assessment. Now, the extension of carbon emission accounting method is based on the CFP approach, that means carbon footprint approach, but it's extended, and in the extended carbon emission accounting method, the labor, capital, raw material, energy, and environmental inputs are calculated as extended carbon dioxide emissions, that is EXCDE. For that, we have to define first the production indicators which are producing the carbon in manufacturing. So the production indicators in case of manufacturing process are labor, capital, material, energy, and environment. So labor is defined by capital letter L, capital is defined by capital K, the material by capital M, energy by capital E, and environment by capital O. When they passes through the production plants or different production processes, and when we carry out the final product with the efficient way, then we can find out the carbon emission with these production indicators. That means the carbon emission with respect to time is the function of labor, capital, material, energy, then environment, product, and efficient way of producing the product in given time. So with this help of production indicators in carbon emissions, we can calculate the extended carbon dioxide emission as sum of MI into EFI. MI is the total of production indicators into efficiency that we are going to define for that particular component. So for this, I have referred few of the journals or the research papers that I have found on various websites. So with this, I am going to conclude my session on sustainable advanced manufacturing process. Thank you. On behalf of all the participants of 4-week International FDP on Environment and Sustainability, organized by Dr. D.Y. Patil, College of Engineering and Research, Akurdi. I'm, it gives me immense pleasure to thank Dr. Vinay Kulkarni, coordinator of this international